In this presentation, we'll be exploring the Bay issue of non-point source pollution. And we'll end up shortening this to NPS pollution. So as many as 32 bacteria-related impaired water bodies exist in the Houston-Galveston area. This makes it one of the highest priority problems facing the Galveston Bay ecosystem. NPS pollution within the watershed has impacted hundreds of miles of bayous and streams that flow to Galveston Bay. NPS pollution occurs when rainfall or snowmelt flows off the land, roads, buildings, and other features of the landscape. This runoff carries pollutants into drainage ditches, lakes, rivers, wetlands, coastal waters, and even underground sources of drinking water. To reiterate what we just learned, let's watch this short video together. Marine debris. Marine debris creates an aesthetic and ecological problem in Galveston Bay. Most of the marine debris found in Galveston Bay is a result of stormwater runoff. Marine debris can harm wildlife by entangling them or by wildlife ingesting items they believe to be food. So the top figure shows debris collected in Clear Creek in February 2008 by volunteers with the Clear Creek Environmental Foundation. Close to 15 tons of trash was collected in Clear Creek alone. The other two pictures show the devastating effects that marine debris can have on marine animals. So in the picture on the left, an albatross chick ingested so much plastic that it perished. And in the picture on the right, a sea turtle became entangled in a lawn chair, eventually washing ashore in South Carolina. So marine debris isn't always in big pieces. So let's watch this video to understand the different forms that plastic can take.
Microplastics? Okay, plastic. We all know what that is. It's in packaging, shopping bags, to-go cups, toys, car parts, synthetic clothing, electrical and home appliances, and plastic bottles. Plastic is an artificially made material, which is why it's technically called a synthetic compound. It's made mostly of crude oil, natural gas, or coal. It's not naturally biodegradable, unlike, for example, compost. That means plastic does not rot and often ends up as trash on the ground and in the ocean. There, the plastic parts disintegrate by heat, wind, and waves, bit by bit, into even smaller parts, known as microplastics. By definition, these tiny synthetic compounds are between 5 millimeters and 1 micrometer long. Even smaller particles are technically called nanoplastics. These shredded plastic waste particles are known as secondary microplastics. The wearing down of car tires, for example, is one of the biggest causes of microplastics. But before this trash is ever produced, the products must first be made. For that, you need primary microplastics. These are small plastic pellets. In industry, they serve as the basic material for every plastic product you can imagine. And plastics are used in various cosmetic products and household products as granules or in liquid form. The problem with microplastics: like large plastic parts, they are not naturally biodegradable. And in cleaning processes in factories, but also in showering or washing clothes, they get into the sewer water. On land and in our water bodies, the crushed particles are moved by wind and waves. Rain carries the plastic into the sewage system. The smaller the particles, the harder it is to filter them. For example, in sewage treatment plants, millions of tons of microplastics are distributed everywhere, and that's increasing. The surface of microplastics is a magnet for toxins and pathogens. Animals, both in the water and on land, confuse the plastic particles with small animals and consume them as food. Through the food chain, the pollutant-rich plastic particles finally reach our plates and make their way into our bodies. Even in our drinking water and our foods, such as salt, honey, or milk, you can find certain microplastics. The consequences of consuming plastic for animals are diverse. Internal injuries and inflammations, hormonal imbalances, illnesses, and even death. The effects on humans have not been researched enough yet. The topic of microplastics is often a hot debate. It's about rethinking and finding alternatives to plastic, and about recycling, so that the amount of plastic and the resulting microplastics found in nature no longer increases. Everyone can do their part.
Excess nutrients. About half the land in the United States is farmland. These nearly 1.2 billion acres produce an abundant supply of food and other products. Activities on working farms and ranches can affect water quality, both locally and across multi-state watersheds. So the National Water Quality Assessment shows that agricultural runoff is the leading cause of water quality impacts to rivers and streams. It's the third leading source for lakes and the second largest source of impairments to wetlands. About 500,000 tons of pesticides, 12 million tons of nitrogen, and 4 million tons of phosphorus fertilizer are applied annually to crops in the continental United States. Soil erosion, nutrient loss, bacteria from livestock manure, and pesticides constitute the primary stressors to water quality. All right, so why is this? Nutrients in fertilizer and livestock manure, pesticides, and other substances don't always remain stationary on the landscape where they are applied. So as we talked about in the first slide, runoff, in addition to infiltration and irrigation, return flows can move these contaminants into local streams, rivers, and groundwater. And rainfall and snowmelt transport actually the majority of these pollutants to surface waters. But there are other factors, so cattle loathing in stream corridors and stream channel erosion that can also degrade water quality. And so the problem here is that increased levels of nitrogen and phosphorus from fertilizer and manure can stimulate algal blooms in lakes and rivers, which ends up leading to the development of hypoxic, which is low oxygen conditions that are harmful to aquatic life. Toxic chemicals. Toxic chemicals such as spilled oils and fuels in cities are often washed off streets, down storm drains, and into water bodies. So combustion of fuels in automobiles and factories introduces hydrocarbons and metals into the environment, and these eventually end up in the water through atmospheric deposition or runoff. Acid rain pathway. So industrial facilities often discharge pollutants into the atmosphere, typically through some type of smokestack. So these airborne pollutants, hydrocarbons or metals, can travel really long distance. And then these pollutants are deposited on surfaces, which is called dry deposition, or they're deposited on via the rain and the snowfall. So this would be wet deposition. So although the pollutants may have originated from a point source of air pollution, such as a factory, the long range transport and multiple sources of the pollutant make it a non-point source of pollution. So acid rain has, really become a major concern in some areas of the United States. And to understand acid rain a bit more, let's watch this video together.
In this video, you will learn that in two quite different ways, the burning of fossil fuels can cause our rain to become acidified. Sulfuric acid arises from the burning of coal and oil, mainly in power stations, whereas nitric acid arises from the exhaust pipes of our motor vehicles. You will also see some of the effects acid rain has on our environment. Firstly, it's important to understand that rain is naturally slightly acidic. Whilst falling to the ground, the rain dissolves carbon dioxide from the atmosphere to form carbonic acid, a weak acid, giving natural rain a pH of 6. It's when we burn fossil fuels that much stronger acids get into our rain to form acid rain with a pH as low as 3. When the pH changes from 6 to 3, what do you think the acidity increases by? 2 times? 3 times? 10 times? 1,000 times? Pause and think. Remember that each change of 1 in pH is a 10-fold change in acidity. So changing from 6 to 3 is 10 times 10 times 10, or 1,000 times more acidic. We'll consider sulfuric acid first. Plants need a little sulfur to grow. They obtain it from sulfates, for example, potassium sulfate, found naturally in the soil. The sulfates are taken up by the plant's roots, and sulfur atoms become bonded to carbon atoms in the leaves' proteins. When plants die and eventually form coal and oil over millions of years, these sulfur atoms remain bonded to the carbon atoms. The sulfur content of coal and oil is usually between 1 and 4% by weight. What do you think is produced when fossil fuels containing sulfur are burnt? Pause the video whilst you think. When the coal is burnt, the sulfur and the carbon atoms join with oxygen from the air and are released into the atmosphere as carbon dioxide and sulfur dioxide. In the presence of sunlight, a photochemical reaction will take place where sulfur dioxide reacts with more oxygen to form sulfur trioxide. This dissolves in the rainwater, forming sulfuric acid. Let's now consider how nitric acid gets into the rain. In the high temperature conditions in the cylinders of our motor vehicles, a small amount of nitrogen and oxygen from the air can react. Remember that air taken in to combust the fuel is nearly 80% nitrogen. So exhaust gases from vehicles contain small but significant amounts of nitrogen oxides. Once the oxides of nitrogen are in the air, they react with more oxygen, just like we saw with sulfur dioxide, and dissolve in the rainwater to form nitric acid. If the rain falls on limestone soils, which are alkaline, the acidity may be neutralized. However, if the rain lands on neutral or acid soils or on vegetation, then it can cause damage. So why is this acidity harmful to living things? Well, living things don't grow well in acid conditions, and it's easy to demonstrate this.
Hydromodification activities include channelization and channel modification, dams, and stream bank and shoreline erosion. So a frequent result of channelization and channel modification activities is a diminished suitability of in-stream and streamside habitat for fish and wildlife. They can also alter in-stream patterns of water temperature and sediment type, as well as the rates and paths of sediment erosion, transport, and deposition. So the hardening of banks along waterways has increased the movement of non-point source pollutants from the upper reaches of watersheds into coastal waters. And excessively high sediment loads can smother submerged aquatic vegetation. It can cover shellfish beds and tidal flats. It can fill in rifle pools, and it contributes to increased levels of turbidity and nutrients. Septic systems provide wastewater treatment for many homeowners who also often get their drinking water from private wells. If a septic system is not working properly or is located too close to a drinking water well, contaminants from the wastewater can end up in drinking water. So non-point source pollution not only affects ecosystems, it can also have harmful effects on the economy. U.S. coastal and marine waters support millions of jobs, generate billions in goods and services through activities like shipping, boating, and tourism, and they contribute billions to the U.S. economy through recreational fishing alone. If pollution leads to mass die-offs of fish and dirty-looking water, deep financial losses often result. Non-point source pollution affects the beauty and health of coastal lands and waters. If the physical and environmental well-being of these areas is diminished, people will naturally find it less appealing to visit the coast. So beaches will not provide the tranquility and leisure activities many people expect to experience. You can see how non-point source pollution plays an indirect, though powerful role in tourist contributions to a coastal community's economic status. The population in many coastal communities is also increasing at a rapid rate. And so the value of waterfront property often relies on environmental and aquatic conditions. Excess non-point source pollution impacts the overall quality of life and subsequently can drive property values down. So if non-point source pollution continues to plague the water surrounding coastal communities, their economies and social conditions may rapidly deteriorate. So what's one way to mitigate this? Well, water monitoring. So the TCEQ, which is the Texas Commission on Environmental Quality, and other organizations collect water quality data statewide in order to develop the Texas Water Quality Inventory. So this inventory includes the identification of surface water bodies that do not meet one or more of the standards defined in the Texas Surface Water Quality Standards. The data also indicates whether non-point source pollution is a contributing factor to the impairment. Now, not only do professionals test water quality, but also citizens can as well. So the Galveston Bay Action Network allows residents to easily report any pollution they see using a desktop, laptop, or a mobile device from anywhere in the Houston-Galveston region. This information is automatically forwarded to the proper investigating authority based on location. So the Galveston Bay Action Network is managed by the Galveston Bay Foundation, which is a Houston-based nonprofit working to preserve and enhance Galveston Bay. And all kinds of pollution found on land and in water can be reported. So types of pollution to report include oil and chemical spills, trash, illegal dumping, illegal discharge of boat sewage, bird or fish kills, submerged vessels, and waters that are abnormally colored or have an unusual odor. So you can even download the Galveston Bay Action Network app on your phone to report pollution. And the icon will look like the one in the lower right-hand corner of this screen. So let's watch this video on water monitoring teams and how you can get involved.
Hi everyone, my name is Nick Ellis, Water Quality Programs Coordinator with Galveston Bay Foundation, and today I want to introduce you to a special group of volunteers at Galveston Bay Foundation called the Water Monitoring Team. They are a small army of volunteers that collect water quality samples at more than 60 sites all around Galveston Bay. We are part of the Texas Stream Team out of the Meadows Center at Texas State University, and they undergo the same initial training and annual quality control sessions that all statewide volunteers undergo.
Galveston Bay Foundation wants everyone to be able to enjoy the bay in a safe and healthy way, whether they're kayaking, fishing, swimming, and our data are used to inform the users of the bay just how safe or unsafe that may be to do.
Our data are used to supplement the data collected in the deeper waters of the bay by various agencies and institutions, since our sites are all nearshore sites where the public is likely to come in contact with the waters of the bay. And just in case you may be interested in joining the water monitoring team, we're going to now show you a quick snapshot of what that looks like in action.
The parameters that our volunteers sample for are air temperature, water temperature, dissolved oxygen, pH, water transparency, total water depth, salinity, and enterococcibacteria.
So, going along with NPS pollution, it's important to be aware of seafood consumption advisories. So, while Galveston Bay is a really excellent place to fish, you need to know what's safe to eat. So, this map above shows the seafood consumption advisories that are currently in place in the Galveston Bay system and its tributaries. And there are 4 distinct advisory areas, and each has its own set of affected species, contaminants of concerns, and consumption advice. And how this exactly works is that when fish and crab eat, they consume toxic pollutants and tainted sediment, water, or prey. And remember, these toxins are coming into the environment because of rainfall runoff from land, spills, leaks, and improper disposal of industrial wastes. So these toxins can then accumulate in the fish or crabs, especially in their fatty areas, so their glands and organs. And this is bioaccumulation. So fish that have higher fat content, such as spotted sea trout and catfish, are typically subject to more stringent advisories than less fatty fish, such as red drum, black drum, croaker, and flounder. And lastly, there are many things that you can do to combat stormwater runoff pollution. So take a look at this list of 12 things that you can do yourself.